Welcome back, everybody. It's a beautiful sunny autumn morning here in Friedrichshafen, Germany. So we actually would like to open the windows, which we unfortunately cannot do here in Hall B4. But we're not opening the windows. We're going to talk about windows together with an expert, and you can become part of this conversation. Just ask your questions, send in your comments, and challenge our experts via the LinkedIn chat or via our email address plus.com@basf.com. Now back to this window and back to my expert for today, Thorsten Herrmann. Good morning.
Yes, good morning, Richard.
How are you?
Good morning. I'm fine
this
morning. Yeah.
How's Fakuma going so far for you?
Oh, very well. I'm very happy that we are back here.
Okay.
And after this phase of Corona.
Absolutely.
Life is back.
It feels good. Life is back. You're right. Actually,
exactly.
I have something I want to talk about with you. This beautiful piece of engineering. What is it?
Yes. As you can see, it's a part of a window, and what interests us very much is the frame of the window here. Usually the frames got bigger and bigger the last times. Architects want to have freedoms, and you need very stiff profiles.
Okay.
And usually you enforce the profiles with steel. This is a common technology, well known. All builders of windows know this.
Yeah.
And for some years we have an alternative.
Okay.
We enforce them with PVC, with PBT, our Ultradur.
Okay.
High filled with glass fibers, what brings very high stiffness and has some very good advantages in insulation.
Okay, so this is a normal residential window I could also have in my house.
Yes,
basically.
exactly.
Okay. So tell us a little more about the comparison to steel. You said stiffness is almost as good, or is it as good?
We have some advantages. So stiffness is steel is a very stiff material, and it's easy to place steel somewhere in the window, and it's enough. It works. We use our material and place it where it is needed.
So it's this green.
Exactly.
The
this
green
is the green material.
Okay.
It's another point. We come to this. It has another color than the rest. So PVC and PBT should have different colors in regard of recycling. But from the stiffness, what is needed, what is the main effect, we need to place it far away from the middle.
Okay.
For an engineer, this is logical.
For me, not for me. Not for me.
And with this co-extrusion technology, and this is the new technology we present here, not using PBT stripes, what is used for years now. So it's placed by co-extrusion, and we have a very high flexibility to create the molds and bring this Ultradur where it is really needed.
Let's stay with that. You mentioned two materials. One is the PBT, BASF's material, Ultradur, and the other one is PVC.
Yes, PVC. This is a real common material for window frames for centuries.
And we have called this little discussion here taking PVC beyond its limits.
Exactly.
Where does that claim come from?
PVC has some very good properties for windows, UV stability, and it's a flexible material. And it will be used in the future for window frames. But PVC, a thermoplastic material, has its limits. So it's temperature above 80, 90 degrees, then all properties will go down. PVC. And in the last years we got more and more dark window frames, and when they are in the summer in the sun, you have quite high temperatures, and you have high temperature differences between outside and inside. And that leads to shrinkage and warpage. And PVC on its own can't manage this. So you will have warped frames, and for this they use steel. And with our Ultradur we can improve it in the same direction and have more advantages. So we can really place it where is it needed and work against all these effects like shrinkage.
And this process is called co-extrusion.
Yes.
Tell me a little more, how can I imagine this to work?
So co-extrusion is in extrusion a common process, but it was not possible so far to co-extrude PVC with an engineering plastics. Because the melting point is very different. The processing temperature from PVC PVC is around maximum 180, 190 so far.
Yeah.
And in standard grade of PVT needs 220, 240. So it was impossible to co-extrude in one mold. And that was a big step that we found a way to reduce the melting point of the PVT below 200 degrees.
Okay.
And now we have 195, 198, and we come in the frame, on the processing frame of PVC, and so it's possible to co-extrude it, use this one-step process to get the ready profile from the machine.
I'm just getting on that topic. I just got a question via email. Thank you for that. Question is, can this Ultradur product also be co-extruded with other polymers and not only PVC?
That's possible.
Okay.
For example, ABS is possible, polycarbonate, PMMA. Not all thermoplastic materials, but this kind of materials.
This is basically a process or technology innovation, like this co-extrusion process. Is this limited to this application, so to these window profiles, or is it theoretically possible to do this for others too?
No, definitely not. So window profiles is large volumes, and there it fits very well. But there are many other technical profiles extruded, and they also come to its limits. And usually you try to use other materials, put more glass fiber in, but I think there are some possibilities where co-extrusion would be the solution, and there this grade would bring the solution.
So you would also be looking forward to new ideas from customers for other applications.
That's what we are really looking for, and we are very interested in cooperations.
Can you maybe mention like one or two things that you have been working on that you are optimistic about, some other applications?
Yeah, there are some few samples, for example, in the area of white goods.
Okay.
It's very close to window frame. It's a frame from a door from a freezer.
Okay.
So it's similar, and so it was not so difficult to find a solution. But we have first discussions with profile extrusion companies to use it all in other kind of technical profiles. But to be honest, we are looking for this applications.
Okay, that's important. So if you have any ideas for where this technology, this co-extrusion process can be used, also feel free to get in touch with Thorsten here. But I have some more questions. One topic I definitely would like to discuss is the sustainability performance of this profile. So can this, co-extruded, can this be separated? What about the waste? Can this be recycled?
Yes, of course it can.
Okay.
So in the using time, brings a good effect. It has better insulation properties than steel, and we reduce heat and reduce CO2. When the life is over, 30, 40, 50 years, long time, then it's possible to recycle, and it's common to recycle PVC, and it's also in production to recycle PVC PVT frames, because you need different colors of these two. When you granule it, and you have granules with different colors, it's very easy with color sorting machines to separate it.
So color sorting or near-infrared sorting would then help to generate kind of homogeneous waste streams.
These technologies got better and better, and it's really possible to separate it completely.
That's good. Another question from the email community here about the tooling. I'm just reading it, is the tooling complex?
It's more complex.
Okay.
So there are some companies who build extrusion tools, not so much. And we cooperated with one, and I can mention it, it's company Greiner Tooling. They have good experience and how to use it, especially with our PVT material.
Are they specialized in these window profiles?
Yes.
Okay.
Window and other kind of profiles, so extrusion profiles.
Really interesting. Thorsten, summing it up, if you would have, let's say 30 seconds to sum up the advantages of this process and the materials, now's your time.
Okay. So as an engineer, I really like this kind of co-extrusion technology to bring the profile ready out of the machine, not adding something further, steel or something.
Yeah.
So this one-step process, and have a profile with such good abilities, stiffness, and reducing or increasing thermal insulation. It's a great product. Yeah.
30 seconds. Exactly. Thank you very much. I'm looking for some fresh air now, and we'll be taking a walk outside. Thorsten and the rest of BASF Performance Materials construction team is looking for customers to apply this great new technology. I'm looking for you to be back later today for our next live stream, where we will be talking about the charging boxes for electric mobility. I'm going to be together with our expert Patrick Fry by then. Until then, stay safe, stay positive, stay optimistic, and get some fresh air. Bye-bye.
BASF. We create chemistry.